Bismillahirrahmanirrahim. Second part of this November 2020 and paper 41. We have done this up to question number 5 so far. Let's start the sixth question. Okay, let me enlarge this a bit so that we can read this easily. Okay, so we have here in this question it says a car of mass 1500 kg is pulling a trailer of mass 750 kg up a straight hill of length itna inclined at an angle of itna. The resistance to the motion of the car. Okay, let me draw that inclined plane over here first of all. So let's say we have the inclined plane like this, okay? And this is your theta over here. Here is your theta. Now the examiner is going to deceive you by giving so weird values associated with the angle over here, okay? So he has given us that the sine inverse of 0.08. So let me say that this sine inverse of 0.08 is going to be theta. So we will be needing that sine theta actually, and that will be 0.08. Okay, so we have a car over here. Here is the car. Okay, and here is the trailer attached to it. Okay, this should be a horizontal parallel to this I mean, this plane over here. I'll be showing tension in both the directions. Okay. Okay, this one is the car and this one is the trailer. Okay. Acha, the a car of mass 1500 kg. So the mass of the car is 1500 kg. Okay, let me show that this weight over here. Come on, this weight. This has to be a vertical line downwards. So here is a weight that is 15,000, okay? And this weight over here is 7,500. Okay, we might need these components towards the, maybe in the second part, okay? So I'm going to show them the components of the weight over here. So this component, let me draw this a bit neatly. This component over here is going to be, you have theta over here, you have theta over here. So this will be 15,000 sine theta times 0.8. So we'll be using that. And this component over here would be 7,500 sine theta. As it says, the length of this hill over here, that is going to be 800 meters. Okay. The resistance to the motion of the car and the trailer as are there 400 and 200 newtons. Okay. So fine, no problem. So there is this 400 Newton force on the car and there is this 200 Newton force, resisting force on the trailer. The car and trailer are connected by a light rigid tow bar. The car and trailer have speed 30 meter per second, okay, at the bottom. So here the speed is 30 meter per second and here at the top it is 20 meter per second. Use an energy method, okay, to find the constant driving force as the car and trailer travel up the hill. So whenever it says the energy method, so remember that cheetah formula that we have, the work done by the driving force minus work done by the resisting force, that is equal to change in kinetic energy plus change in the potential energy. Now, work done by the driving force. We have to find the driving force basically. So let's keep it as work done by the driving force. Later on, we'll divide that by 800, okay? So we'll be able to determine that driving force, okay? Minus work done by the resisting force. Let's consider this as one system. Let's take this as one system over here, okay? So collectively there is a 600 Newton backward force onto it. So the backward force is 600 times the distance is going to be 800. Please get your calculators ready, okay? Now altogether their mass is, the total mass over here is bacho, that is the total mass is going to be 1500 plus 750, that is 2250. So half into 2250 into the final speed is 20 square minus the original initial speed, that is 30 square, plus change in change in the potential energy, that is mgh. So total mass is 2250 into g, that is 500. Now the final height is going to be, let me extend this up to here. This is the final height gain. Can I say this is going to be 800 sine theta, Hannah? And this is going to be 800 into 0.08, and final height and initial height is 0, okay? So you can write minus 0 over here. So this is the work done with the driving force minus work done with the resisting force, that is equal to change in the kinetic energy and plus change in the potential energy. Now please don't be confused with this weights component over here. Some people um, add this into the resisting or the driving force. Remember, whenever you're dealing with the potential energy, change in potential energy, do not try to make this weights component as a part of the driving force or a part of the resisting force, because this has already been considered here while determining the change in the potential energy. Now, please use your calculators and tell me what is the work done by the driving force. Now, you have to do all this manipulation. This thing will go to the other side. This will be added into here plus 480,000 here. Okay. Now, whatever you get, that will be the work done by the driving force. I'm leaving that up to you. And now we have to find the driving force. So let's assume the driving force is going to be F times the distance 800 equal to this answer over here. You simplify this, you should be able to get the driving force. And that should be, let me see the answer from here. This should be, it is question number 6a part, that is 1700 Newton. It should be 1700 Newton. Please confirm that if you're getting this 1700 Newton or not. This should be your answer. I'm waiting. Okay, we got the confirmation that the answer is right. Well, let's see what is there in the next part. I don't want to erase all this diagram because I might have to use this in the next part. It says after reaching the top of the hill, the system consisting of the car and the trailer travels along a straight level road. The driving force of the car's engine is this, and the resistance to the motion are unchanged. Find the acceleration of the system and the tension in the tow bar. Okay, so now since it is going to be a horizontal situation, so I have to erase all of this. Okay, remember 200 and 400. Okay. Now these are going to be on a horizontal here, on a horizontal road. Okay. So this is the road here, and we have the car. Here is the car going. Here is the trailer going. Okay. This is the car. This one is a trailer. Okay. And it was facing a force of 400 Newton, resisting force. This was 200 Newton. What was the mass of the car? 1500 kg. And the mass of the trailer was at 750 kg, and here the speed was 20 meter per second. Okay, the driving force, now we have the driving force as well. Okay, good, cool. We have the driving force here. Good. That is, come on, this driving force over here is 2400 newtons. Okay, and we have to find the acceleration of the system. Okay, so the forward force is 2400 minus the backward force, that is 600. Total mass is what is the total mass? That is 2250, Hannah, times the acceleration. So this is 1800 over 2250. That is the acceleration. Let me check the answer. Please use your calculator. This acceleration has to be zero point 0.8. Is that zero point 0.8?
Yes,
जी
sir.
सर.
Okay, that's a good news. That is zero point 0.8 meter per second square. Now we have to find the tension in the tow bar. Now here is the tension, here is the tension. Now you can consider just the trailer, or you can consider the car as well if you want to determine this tension, because this is the tension that is pulling this trailer forward here. So the on the trailer, I'm going to focus on the trailer, Vacho. Okay, on the trailer. So forward force is T, backward force is 200. Don't be confused with this forward force. This is the forward force acting on the car. Okay. When we took this as a system, so this T was cancelling this T. So the only forward force was 2400. The only backward force was going to be this 200 plus 600. Now I'm going to focus purely on the trailer. So trailer is being pulled by the tow bar, which has a tension T forward in forward direction. So backward there is 200. We know its mass, that is 750, and we know its acceleration as well, that is zero point 0.8. So this way you will be able to get the tension. That would be, what is this tension now, Bacho? Hmm? Is that 800?
800, sir.
जी
Oh,
सर.
okay. So this is 800, which is the right answer. Okay, that is 800 newtons. If you have any question, please let me know. Otherwise, I'm going to move on to the last question of this paper. Okay, here is this seventh question. Okay, it's the 3 points A, B, and C lie um, on a line of greater slope of a plane inclined at an angle of 30 degrees to the horizontal. AB is 1 meter, BC is 1 meter. Okay, as shown in the diagram, a particle of mass 0.2 kg. Okay, I love showing this weight downward here. So here is this weight 2 newtons, and we have to resolve this parallel and perpendicular to this surface. Okay, so this is going to be 2 sine 30, and this downward is going to be 2 cos 30, because if you have this angle as 30, so this angle here is going to be 30 degrees as well. Here is going to be r if there is any rough surface, so this will help us to determine uh, the resisting force. Okay, acha. So guys, it says particle of mass is released. So release means the initial speed is going to be zero. Okay. Okay. Released from rest, and like release from rest. So initial speed is zero. Slides down the plane. The part of the plane from A to B is smooth. Okay. So there is no friction over here. Only the downward weight would be, pushing this downward. The part of the plane from B to C is rough. Okay, with coefficient of friction mu. Okay, now this R is going to be helpful over here. So your R is which, so that is 2 cos 30. Okay, and if you simplify this, you get under root 3, because cos 30 is under root 3 over 2. And then the frictional force, which will be acting up here, that frictional force, let me write it as Fx. So that is going to be mu r. So this is under root 3 mu, that will be the frictional force acting from B to C. Okay. The part of the plane from B to C is rough, with the coefficient of friction this between the plane and the particle. Given that mu is given. So this is going to be 1 over 2 under root 3 times under root 3. So the frictional force is going to be 3 by 2 newtons. Okay, this is 3 by 2 newtons. Given that mu, just find the speed of the particle at c. Oh, so this is going to be divided into two parts. I think this is an easier question. You will find the speed v, and this v would be u for the next journey. Okay, and you have to find the acceleration from a to b. So let's deal from a to b. Initial speed is 0, acceleration is going to be 2 sine 30. There is no resisting force equal to mass, which is zero point 0.2 into the acceleration. So this is going to be 1 into 5. The acceleration for this part is 5 meter per second square, and the distance covered is being 1 meters. We have to find the final speed. Okay, so this is going to be 2as, that is v square minus u square. So 2 into 1 into 5, that is 10, that is v square minus 0. So let's keep it v square for this, and this v square is going to be equal to the u square for the part which is from B to C. And now, bacho, I believe you people are with me, okay? From B to C. Now, when it is going to go from B to C, the acceleration will change now, because from A to B, there was just one force. That was this weights component that was taking it down here. This is still taking it down, but there is this resisting force acting on it. So, bacho, let's get from B to C, let's find the acceleration. We know that the initial speed is going to be, we need just u square, that is 10. We have to find the final speed. We have the distance, which is 1, but we have to find the acceleration. We'll find that through F equal to ma. Downward, we have the force, that is 2 sine 30, and the backward force is 3 over 2. Mass is zero point 0.2, and we have to find this acceleration. This is 1 minus 1.5. So this acceleration is going to be minus half meter per second square. Guys, I believe you people are using your calculators. Keep a check on my answers here. Okay. So now we have to find this. So I will be saying 2as. 2
Sir, minus 2.5 नहीं है.
Yes, sir. It's minus 2.5.
minus 2.5. Why?
Acceleration, sir, calculate कीजिए
Oh,
sir.
I ignored this point too. Thank you very much, beta. I thought this is just A. So this is going to be minus 1 over minus 5 by 2, है ना?
जी sir.
है ना? Minus 5. Thank you very much. That is why I was asking you people to stay alert. 2as, that is equal to v square minus u square, है ना? So this is going to be v square is going to be 5, and your v is going to be under root 5. Anna? So let's
जी
check
sir.
the answer. Under root 5. V square B is going to be 7. It says under root 10. Come on, what is going wrong here? It says under root 10. What did
नो
I?
सर वो नीचे लिखा हुआ है वो सिर्फ b की वेलोसिटी है √10.
Acha, oh, let me see this again then. And the velocity at C. Oh, yes, that is right. It is here, under root 5. Oh, thanks God. So that is the correct answer. Under root 5 is the right answer. Okay. So you see that this question was not difficult, but it was a bit lengthy. Okay. Now let's look at the B part now. B part. Given instead that the particle comes to rest at C. Oh, so now we have to find the value of mu. It is going to be at rest at C. Okay. So we have to find the mu. Okay. So this means this first part, this first working will remain as it is. We'll be removing all this. Okay. Let me clear this, all of this. Okay. So now we're given that V is 0. है ना बच्चों? Given that V is 0 and the frictional force remains this. है ना? Let it be in terms of mu. That is a frictional force. And we are going to apply that F equal to ma again. So F equal to ma. Forward force is 2 sine 30. Backward force is under root 3 mu. Mass is zero point 0.2 and acceleration still has to be calculated. We don't know what is the acceleration, okay? So this acceleration is going to be 1 minus under root 3 mu into 5, है ना? Because zero point 0.2 is 1 over 5. This is a kind of a over 5. So 5 is cross multiplied here. So this acceleration is this. So guys, we have final speed 0. We have this. We have distance covered equal to 1. Let's put all of that into the equation once again. So 2 into 5, 1 minus under root 3 mu into the distance which is 1, that is final speed is 0 minus u square, that is going to be 10. है ना? है ना बच्चों? Okay.
जी
So
सर.
let's simplify this. Let me clear all this area so that I can do some working here. Acha bachcho. So this is going to give me now 10 into 1 minus, I'm not using the calculator at all. This is equal to minus 10. So 10's cancel, we have minus 1 here. So 1 minus under root 3 mu, that is equal to minus 1. Minus under root 3 mu is equal to minus 2. And mu is equal to 2 over under root 3. 2 over under root 3. Let me check the answer, the last answer. Yeah, this is, you can see it is here, it is 2 over under root 3. So guys, this ends our paper here. Thank you very much for being with us. If you have any question, let me know.